Hello, everyone. I'm Edmund Miller. I'm a PhD student at the University of Texas at Dallas, an NF core maintainer, and I'm also a bioinformatics engineer at Element Biosciences. Today I'm going to talk a little bit about workflow automation and using the AVITI benchtop sequencer and Nextflow Tower. So I hope you like automation after that last talk. So things that we're going to cover today: a quick introduction to the Element AVITI System and what that is. And then we're also going to talk about the importance of efficient FASTQ generation for analysis. And then we're going to talk about NF core demultiplex and show a little automated NF core demultiplex with Tower. So here at Element, we have built a sequencer called AVITI. Some highlights for you. We can do more than 1 billion read pairs. It's dual-sided, so you can have two runs going at once as well. And our read links are 150. And then you'll notice our data quality down there is greater than 90% Q30. There we go. So we have a very compatible and highly flexible NGS sequencing platform. That's our goal, is to give our users freedom and flexibility. We have several end-to-end content solutions that we've been partnered with as well. On the right there, you can see the Element Cloud, and that allows you to manage your runs in your fleet there. And then from that, the entirety of NF core is available and compatible with that because we just produce FASTQs as per usual. So we also have no specialized FASTQ formats, just Fred plus 33. There's also no specialized LM Bio specific workflows. All of these existing tools that are listed above are compatible, and it's just a drop-in replacement for NGS solutions. So FASTQ generation may not be something that everyone's familiar with, but generally sequencing machines output base call files, and then they need to be transferred into FASTQ files. And those FASTQ files are common formats for NGS output. And we typically call that primary analysis instead of secondary analysis. So there are a couple challenges with generating FASTQs. The data must be transformed into the FASTQ format for use downstream from bases. So the data can be quite large, hundreds of gigabytes to several terabytes even. There's a couple reasons to automate it. We can avoid manual touch points and enable scalability. And then there's a couple of reasons to stream to the cloud on this as well. Then we don't have to have a whole bunch of local storage. We can also avoid lengthy transfer at the end of the run instead of transferring to the cloud after we've finished the run. And then we can also offload the storage and analysis, which frees up the instrument, which is the most precious resource of that, for more runs. And then there's also additional computation that can happen downstream, such as adapter trimming, barcode demultiplexing, and EMI handling. So this is the commonly used infrastructure here. So you sequence on a NGS instrument, you output the base files to local storage. The 24/7, 365-day bioinformatician then waits for the run complete, kicks off the FASTQ generation software, and then reviews the QC results and proceeds to manually, and then proceeds to secondary analysis. I think we're all familiar with that. And then, if we enable automated FASTQ generation based on that, suddenly the bioinformatician is out of the picture on that. So we can sequence on AVITI, output the base call files based on that, and then we can wait for the run uploaded file or event, and then we can run FASTQ generation software based on that on Tower, and then we can review those QC results and move on to our secondary analysis. So there's a proposed workflow here that we're calling 5 steps to FASTQ freedom. So the pattern employed here can be further extended into secondary and tertiary analysis downstream from that FASTQ generation. In this, we leveraged AWS Lambda, and similar triggers are possible on other platforms as well. The LM Bio Cloud is a lightweight connection and run manager, and from that the users can choose their cloud/platform of choice. We don't tie you into any specific vendor of those, and we try to support the major ones. And then we have a run uploaded event, which is a AWS event bridge that's coming soon. And that'll enable deeper run QC, advanced logic to guide demux and FASTQ generation based on those, and whether you can maybe not, or maybe make some changes on that automation that's a little bit smarter than the run completed. And then with AVITI and basis to FASTQ, we can make the FASTQ generation and read processing easy and do all of these downstream steps as well that we'll cover. So at Element, we have a BYOB policy of bring your own bucket. This is an overall theme that I've seen through some of these presentations this week as well, of democratizing the data and it being in your own bucket. So yeah, we support AWS S3, Google Cloud, local. We can have a Tower integration as well that then allows you, and you can see down there at the bottom, that's just a picture of the Element Cloud software, and you can manage these integrations directly. So we go straight from the machine to the cloud, no intermediary, kind of like Fusion in the similar concept of you can scale infinitely. Highlighted down there is the run completed.json, and that's what we're waiting for, and then we're triggering just off of that put event in the S3 bucket. And so from that, to give a little bit of perspective, Graham from Seqera posted a blog post that I recommend you go read on workflow automation and published a Docker image along with that that kind of inspired this. And so we wanted to use that, and then we thought the easier thing, rather than trying to change his Lambda because it just kicks off the job based on the sample sheet and the creation of the Tower data set, we just worked our way back and instead created the sample sheet from the run upload.json event, and then creates that, uploads it to another S3 bucket, and then from there that triggers Graham's Lambda, and then that kicks off Tower. So we also wanted to support the Nextflow community, so we made sure that we had support for basis to FASTQ in NF Core demultiplex. We recently released version 1 as well, and this is in collaboration with Mateus. And you can see the pipeline over there on the right. And so that has several different support for other demultiplexers as well, and I highly recommend you check that out. So from that, then we have a quick Tower run here on the left side. And as you can see, that's just running through a single run on demultiplex. And then from that, we can produce FASTQs in about 32 minutes on a 12x large for only about $1.46, and that's using on demand. And then there's some stats over there on the right side as well of our read length and the read pairs there. You can also note the %Q30, which is 96.2, and the %Q40 is 85.4. And then you can also see that we have coverage of 99.3 X of the whole genome sequencing sample. So let's talk a little bit about basis to FASTQ as well. This is our demultiplexing software. It does some cool things that are a little unique to it and kind of special. So it does built-in adapter trimming. So rather than adding another step downstream, we found it's much faster just to trim the adapters as you're demultiplexing and speeds up the pipeline significantly on those. We also generate run QC stats out of that, and you can see the HTML report on the right there. And then there's also optimized execution, so we can generate FASTQs in as little as 30 minutes. It's also a CPU-based solution, so there's no specialized hardware required. And then it's also a very flexible distribution of we distribute it as a Linux distributable or a containerized Docker image. So just to walk back over what this kind of infrastructure is and what you could do yourself as well. So you can sequence on AVITI, stream directly from AVITI to the cloud, and then from that you can wait for the run uploaded.json, produce a sample sheet from that, and then from that sample sheet we can kick off a job using Tower actions and another Lambda, and then we can review those QC results, and then we can continue doing this downstream as well once those FASTQs get dropped into the cloud and really just scale these out infinitely. So a couple of conclusions. If you're interested in playing around with our FASTQs, there's a link to those that were used in today's presentation. And then there's also, if you want to go play around with basis to FASTQ, we have a Docker and binary that's freely available. Basis to FASTQ is also integrated into NF-core multiplex, if you'd like to see how that kind of works in practice and how we've wrapped that. And then we've also demonstrated an example of an automated FASTQ generation on AVITI using AWS and Nextflow Tower in a very simple way. Thank you.
Okay, a lot of questions on this one, so I'll try and get through this. First, well, it's a little more personal. How do you combine being affiliated with a company in a PhD program as well as being an NF-core maintainer? And being awesome as well as is.
It's a lot of fun. They kind of blend in together. I'm glad that Element supports my NF-core work as well.
And so, yeah, it's quite integrated as well. How do you handle any kind of LIMS systems here? How do you see this being used?
Don't quote me on that. I believe that we hook into some LIMS software as well, is kind of the idea, but if anyone's interested in that, I can get you more information on that.
This one's from Alan. I believe that you may have covered it, but are the base calls and the demux tools different from the drop-in replacements? I guess it's...
Yes.
Yes.
They are our formats.
Another one from Alan, the approach that you showed there using, essentially using a Lambda function, have you considered trying like the watch path channel, so essentially watching for those files?
Like watching on a local drive? Is that
Yes, exactly.
No, we haven't tried that. I assume you could do that as well. You saw that in the previous presentation, similarly with the cron job.
There's a question of, is there a version of the workflow that does not use cloud services?
For all of this, that's why we actually integrate into NF-core demultiplex. We just wanted to give customers an easy way to run it wherever you want to, be it HPC, cloud, wherever, and that's kind of what NF-core enables on that.
And then on the adapter trimming, how does that compare to the BCL convert BCL to FASTQ?
In what way? So I can't speak to BCL convert. We trim, or we have options to trim as you're demultiplexing.
Okay, awesome. There's a comment from Alex. Really appreciate the strong emphasis on the platform openness and the possibilities for integration. And one final one from Christian is asking, is basis to FASTQ, the binary also available in ARM? He only found a version in x86.
I don't know if we have an ARM Docker image built yet, but if you're interested in that, feel free to reach out and we can definitely see if we can make that happen.
Awesome. Thanks a lot.
Thanks.